Mr. Abbott here, and it's time for a boring diagram explanation. This diagram comes from topic 8. Looking at this, you'll see that it's labeled the hydrologic cycle, but most people are going to call this the water cycle. Now, there are definitely things that are left out of this diagram that I'm going to add and include that are part of the processes that make water a renewable resource on our planet. So the first thing that I would add is I would add the sun. Okay, none of this would happen unless you had the sun as the source of energy that's going to fuel or power the water cycle. It doesn't really matter where we start, but you do need to realize that the sun is what provides the energy that makes this entire system work. Why don't we start with factors that add, or processes that add moisture into the atmosphere. So when you're looking at this diagram, you have number 1 and you have number 4, and both of these indicate that moisture is going into the atmosphere. Now, if I look at 4 is probably the most important process. 4 is evaporation. Okay, you should know that evaporation is the phase change from a liquid to a gas. When evaporation occurs, this is where you need energy, so it takes 2,260 joules per gram for moisture to evaporate. Now, this adds most of the water into our atmosphere. Okay, when we look at the oceans, okay, the oceans account for something like 98% of the water on the planet, and that's salt water. Okay, that only leaves us with about 2% fresh water, and that fresh water is found mostly as ice, but it's also found as groundwater. Okay, it's also found in lakes and streams. What's important with the water cycle is it constantly is providing fresh water to us. So that's one of the things that makes water a renewable resource. So if you look at the term renewable resource, okay, renewable resources are regenerated in a short time period. And the fact that water is regenerated, it's not evenly distributed, but it is regenerated, is essential for us. Now, number 1 is showing you the process of transpiration. Now, transpiration essentially does the same thing as evaporation. It takes liquid water out of the soil and returns it as water vapor to the atmosphere. Okay, so if you're looking for a description of that, that's loss of water vapor by plants. You constantly have to water your plants because constantly moisture is transpiring back into the atmosphere. Now, frequently they will take those two processes and lump them together. So you'll see the word evapotranspiration, and evapotranspiration is going to be the process that adds moisture to the atmosphere. Now, this is going from 1, which is transpiration, directly to 2, that's precipitation. They left a really important, step out between those. So I'm going to ask you to add step 5 and put step 5 here in the clouds. Okay, the process that has to occur there is condensation. Moisture enters the atmosphere by evapotranspiration, but condensation is when water vapor in the atmosphere goes from the gaseous phase back to the liquid phase. Okay, if evaporation is going to take in 2,260 joules per gram, condensation is going to release 2,260 joules per gram. So as a cloud forms, it's going to be heating the atmosphere around it. So a lot of energy gets into our atmosphere indirectly by condensation. But condensation removes moisture from the air. Okay, condensation definitely causes cloud formation. You know that condensation is going to occur when the temperature equals the dew point. And on this diagram, you'll notice the bottom of the clouds is flat. They referred to that as cloud base, and cloud base is whatever altitude it is when the temperature equals the dew point. All right, so 2 we said was precipitation. Okay, precipitation is definitely going to be where solid or liquid water particles, so solid or liquid water falls from the atmosphere. Now, when it hits the Earth's surface, there are a number of things that can happen. Honestly, on this diagram, they didn't label or describe what those processes are. So I'm going to add number 6. Number 6, I'm going to put right here, and that's representing those arrows. You know, depending on the surface, when liquid water strikes the surface, one thing that it can do is seep into the surface. We call that process infiltration. So infiltration is when water seeps below the surface or into the surface. When it does seep below the surface, infiltrate, they might use the word percolate, it becomes groundwater. On Long Island, groundwater is a really essential resource for us because honestly, that's where we get our drinking water from. Now, there is an arrow here that I'm going to label arrow number 7. Arrow number 7 is when the water doesn't go into the surface, but it flows across the surface. That process is called runoff. And it really depends on a bunch of factors that we will get into later. But runoff is when water flows across the Earth's surface. All right. When that happens, it's going to collect in lakes, streams, rivers, but eventually it's all going to return and it's going to be pulled back by gravity to the oceans. Now, one thing that we haven't discussed in this diagram yet is what they show you as number 3. So number 3, I would essentially tell you, is groundwater movement. Groundwater does not stay in place, okay? If the soil, if the particles that the groundwater is in are connected, the groundwater can actually flow and move subsurface. So you're getting the movement between the spaces or particles, we're going to call them pores, within the groundwater system. And you'll see that groundwater eventually does return back into lakes and streams and eventually makes its way back into the oceans. So groundwater movement means that water below the surface or subsurface water moves Okay, this can occur if the layers are permeable. Okay, so when we're talking about groundwater movement, groundwater is able to move through layers that are permeable. There are some impermeable layers that are subsurface that do not allow groundwater to flow through them. If you have solid bedrock, the moisture can't flow through that, and that's going to set up different areas. Looking at the model up top, you'll see they've sort of indicated two areas. One is called the zone of saturation. So if I go back to the diagram, up here for the zone of saturation, the zone of saturation has the pores filled with water. So below the boundary in between these zones, the spaces are completely filled with moisture. The area above it is referred to as the zone of aeration. Now, within the zone of aeration, there's water clinging to the soil particles, but there's also, air inside those particles. Now, the boundary between the zone of aeration and the zone of saturation, that top is referred to as the water table. Okay, and movements or changes in the depth of the water table really depend on the amount of evaporation that occurs. It also depends on the amount of infiltration that happens in an area. So there's one basic diagram of the water cycle. The water cycle is constantly bringing fresh water back onto the continents. Honestly, 70% of the surface is covered with oceans, so most precipitation simply falls back into the ocean, but there is constantly a supply of, free, clean, fresh water that circulates between the atmosphere, the hydrosphere, and the lithosphere, and that entire set of processes is called the water cycle. I hope that helps. Take care.